Hi everyone. In this video, we talk about the types of tokenizers. So why do we need to have a types of tokenizer, and we understand different type of tokenizers, and then we will see in each with respect to each application perspective, right? So we will walk through in this video. So we have a types of tokenizers. We have, for the first one is I could say the word tokenizer that we discussed in the previous class, right? So word tokenizer is basically it breaks every sentence into a different words, right? So that is what is word tokenizer. Let's say if I am writing this, right? I am traveling to London, example. So if I do this, right, after, let's say after you perform the text pre-processing and then like a stop word removal and then stemming implementation, then it becomes travel and London, right? So because of the stop words I am and to, it has removed, right? And then we also have stemming performed. So this word tokenizer is basically, right, you convert like every sentence of like every you break down each word of these sentences into different words, and then you perform all text cleaning. All this you can also do. But so now, what is the advantage and what is the disadvantage? The advantage is simple. It's like it's a simple tokenizer. It will be very fast, and then it will be break down into each word, right? But what are the disadvantages? The disadvantage is like when you are building kind of translation, the summarization, right? So whatever the training data that you have, you see all the entire vocabulary, and then you build your own vocabulary, right? So that's where we normally build a vocabulary by looking at the training data, and you break down, you clean the data, and then you apply the tokenizer, right? So you see only the unique words that is in the training data. But let's say if you get a new data which is not seen, okay, and then you may also see kind of variations that you could see, right? So a lot of variations, maybe sometimes out of vocabulary, like which could come, right? So hence that kind of variations this word tokenizers cannot handle, right? So that's what one of the biggest disadvantage. And mostly it is used, the word tokenizer, where it is a simple, and then where it is required you can easily apply, and then we don't need to take so much time, and then you can simply apply word tokenizer. If you want to analyze, like let's say word to word similarity, I want to find out, and then I want to identify the word dissimilarity, a kind of sentiment analysis, like a plain like classification algorithms that you can free to apply the word tokenizer. But now the next important is the to overcome these out of vocabulary and then kind of variations that you see, right? So we have the Subword tokenizer, which is the very famous in the deep learning side of things, right? So when you say Subword, the traditional Subword tokenizers are the BPE, byte for encoding the tokenizer, and then also we have a word piece tokenizer. These are like famous that we usually use in the industry. The pre-trained models, like in the transformer based architectures, usually the byte for encoding and the word piece tokenizers are usually the famous. So how it will start is, ideally it will start with the each character, and then it depends on the frequency of the pairs, right? It merges, it starts merging every character to the next character, and then it starts like by looking at the frequency of these the different pairs, and then we start merging, and then we finally make a vocabulary, and then that vocabulary is not fixed length, right? It like each word, if it is not a fixed, it could have 2 words, like 2 in character length, 3 in character length, 4 in character length, and then multiple character length, right? So the Subword tokenizer, it is not like the fixed set of words that we are taking exactly the same, like the words that you appear in the word tokenizer. Some words are also dropped, and some words like also it can break down into the different subwords. That is what is the advantage. Like whenever you see a new data that it comes, it can handle that variations, right? So that is what, if it can handle even rare words which are unknown words which comes from the test data, that is what is it is most powerful, right? So example, if I draw this apple example, right, it can break down, the apple has, let's say, A P and then PLE. So like this it can also break down. So that's what is the subword tokenizer, right? So now it is mostly used in terms of where it is used is mostly text generation, summarization, and then also translations. That is what is mostly used in the industry. And most of the pre-trained models are existing pre-trained models like in the transformer based architectures like the Bird, Robot, or XLNet, XLM, or the T5 GPT models, right, that you see in the deep learning, right? So it's mostly used in the subword tokenizer, which is either byte for encoding or the word piece together, and then the latest editions also there. But now these are the starting algorithms, the tokenizer in terms of the way that BERT uses the word piece tokenizer, and then T5 or some other algorithms uses the byte for encoding. So that's what is these are the traditional tokenizers that is used in the deep learning frameworks, right? And then we do have the third one is the character tokenizer. Okay, so character tokenizer, what is the advantage of character tokenizer, right? The character tokenizer is ideally, right, so where you do not have the gaps in between the words, right? So that means, right, so where it is do not have a concrete boundaries, where the words do not have a concrete boundaries, like example, like kind of languages that you take a Japanese example, right? So you do not have a concrete boundaries for between the words, right? So hence you need to understand the kind of variations that you see in the particular sentence. So you need to go for the character tokenizer. So character tokenizer is also used in the handwritten recognitions and all. So that is one of the famous in the, like if you see the same example like Apple, right, it will break down to, right, so the A comma P comma P comma L comma E. So like this, that every character will become a one token. So that's what is the character tokenizer. Then we have there is a one more tokenizer is also there, like sentence tokenizer. This is also a famous in the industry. So sentence tokenizer we call, right? So the sentence tokenizer is ideally, right, where we break down, like from a paragraph we break down to different sentences, and then usually this is famous in the mostly used in the topic modeling and all, right? So where you need to understand the entire sentences, and then we understand this topic modeling is a kind of clustering technique, so it's mostly used in that particular sense. And then also you can use in the summarization as well. So like if you see like let's say example, I love NLP, right, and NLP is good, example. So this is the sentence you got, right? So now example, you break down this into I love NLP, right, and NLP is good. So this is the sentence, and earlier this was a completely a sentence, and now your tokens are become two tokens. I love NLP is one token, and then NLP is good is another token. So that is what is a sentence tokenizer, right? You can also have custom tokenizer. So the custom tokenizer is basically like the fifth one, custom tokenizer, right? So custom tokenizer is ideally, right, let's say I have this particularly, let's say check NLP course at rkanalytics.com, and you could see NLP and let's say AI, right? So this is what I have used. Then I can use the tokenizer like this, right? So I can break down to check NLP and course and rkanalytics.com, and then hash NLP and also hash AI. So this is how it becomes the custom tokenizer. You just capture only the HTML or the website rkanalytics.com, and then that how you can also specify your own customization. So now basis on this, based on the application, based on the usual in the based on you look at which tokenizer would help you in a better way. So based on that, accordingly you need to take this tokenizer. More majorly in the used in the industries, like if it is a rare language, if it is not a separable, but we don't have concrete boundaries between the words, then you can obviously go to for a character tokenizer. And the character level, if you want to operate, then character tokenizer you can apply. The words and subword tokenizer tokenizer is usually the Subword tokenizer is a little complex, but it handles the lot of variations, either morphological variations, like maybe the same word I can appear in the it can appear in the different context, right? So that kind of variations it cannot handle. This word tokenizers usually does not handle these kind of variations. So Subword tokenizer is really famous there. So I think this is what is the mostly famous and the champion of the entire tokenizer. So it is mostly used in the industry. The word tokenizer, it is a very simple one, and it can use, like if you want to identify the relationship between the words, and then like kind of word to vector that you see the word between the similarity, all this, the word tokenizer would also help you, right? And then sentence tokenizer, if you want to build a kind of topic modeling between the sentences, and then also if you are building a kind of summarizer on the sentences, that could also sometimes you can also and you to extract the sentences between the paragraphs, then sentence tokenizers can also